everyone, welcome back to our AS level further mathematics past paper walkthrough. I'm Hyan and I'll be your video host, and Siddharth will be our contributor who will explain to you all the key things that you need to know while doing paper winter 2024 and paper 11. So are you ready? Let's get started.
Yeah, hi guys, I'm Siddharth. I'll be solving the October 2024 paper 1-1. Let's start. So the matrix M represents the sequence of two transformations in the xy plane given by a stretch parallel to the x-axis by a scale factor k, followed by a shear with the x-axis axis fixed with 0, 1 mapped to k1. So what this actually means visually is that if we have the xy plane like this, so the two base vectors I hat and j hat. So the regular coordinates of I hat are 1, 0, and the regular coordinates of j hat is 0, 1. So I hat is stretched. So first what's happening is that I hat is stretched by scale factor k. So its new coordinates will be k, 0. So this is the first transformation. So in a matrix, what the first column represents is the coordinates of I hat after the transformation. So that will be just be k0, and since j hat stays fixed, it will be 0, 1 only. So that's the first thing. And then the second transformation, so let's write first here. The second transformation which is happening is that the j hat, the 0, 1 vector, is mapped to k1. So it's like going here. Okay. So now the I hat stays fixed. And basically k becomes the new 1, 0. So we just write it as 1, 0, and this becomes k1. So we can just multiply these two matrices and we'll get our result. So we'll do 1k, 0, 1 and k0, 0, 1. So remember that the first transformation has to be on the right side because it's the order is from right to left. So this will be 1k plus 0 times 0. This will be 1 times 0 plus k times 1. So will be k times 0 plus so this will just be again k times 0 plus 0 times k, and this one will be 0 times 0 plus 1 times 1. This just becomes k 0, 1, which is what M is. That's the first part. So the transformation represented by M has a line of invariant points. Find in terms of k the equation of this line. So invariant line just means that before the transformation and after the transformation, the line just remains the same. There's no change to it. So we can represent this like this. So it's k0, 1 times xy stays as xy. So the vector xy is basically just mapped onto xy again. So now we can write a pair of simultaneous linear equations. So this will become kx plus ky is equal to x, and 0x plus y is equal to y. It's just y is equal to y. Just looking at this part, so we get ky is equal to x minus kx, just x into 1 minus k. So ky is equal to x into 1 minus k. So y is equal to 1 minus k by k x. So this is the equation of the invariant line. Okay. So unit square in the xy plane is transformed by M onto the parallelogram P. So the xy plane, so the unit square which is formed by I hat and j hat is mapped onto a parallelogram P, something like this. So find in terms of K a matrix which maps P back onto S. So the matrix M maps S onto P. So we need to find another matrix, which in this case will be the inverse matrix M inverse, which maps P back onto S. So the formula for inverse matrix is, given a matrix like A, B, C, D, the inverse matrix will be 1 by AD minus BC into DA minus B minus C. So our matrix M was KK01. So KK01. The inverse matrix will be 1 by K into 1 minus K into 0, which is just K, into 1K minus K0. This just becomes 1 by K times 1 minus K0 K. Yeah. Okay. Given that the area of P is 3 K square units, find the possible values of K. So what the area, when we the transformation that happens onto the unit square, so the area of the resulting shape will just be the determinant. So area of P is equal to determinant of M. So 3K square, and because K can be both positive and negative, means it can, in some scenarios, it might be even going like this, in which case it would be negative. We take the absolute value. So the determinant is equal to AD minus BC again, which we just calculated as K. So 3K square is equal to absolute value of K. So that means 3K square could be equal to K, or it could be equal to minus K. So we can't take K as equal to 0, because that would it's not allowed, basically. That makes the transformation meaningless. So we can put K is equal to, so just K is equal to 1 by 3, and K is equal to minus 1 by 3. So these are the two values of K. Okay, prove by mathematical induction that for all positive integers n, the nth derivative of tan inverse of x is, we can write it as Pn of x times 1 plus x squared to the power minus n, where Pn of x is a polynomial of degree n minus 1. Okay, so the first thing is we'll check. So basically the format for proof by induction is just three things. We check for n is equal to 1. So check d1 by dx of tan inverse of x. So by just checking the formula sheet, we can just get that it's 1 by 1 plus x squared, which you can write as 1 plus x squared to the power minus 1. And since it's the first derivative only, the polynomial of x will just be 1. Basically, it's x to the power 0. So it's just 1, which is what we have here. So it's true for, the formula is true for n is equal to 1. So you have to write in the exam, check for n is equal to 1. Okay. Then we write for let's assume that for n is equal to k, dk by dxk of tan inverse of x is equal to pk of x into 1 plus x squared to the power minus k. So this is just our assumption. So after assuming, now we'll check for n is equal to k plus 1. Okay. So let me just create a new slide with the empty. Just give me a second. So let's check for, so dk plus 1 by dxk plus 1 of tan inverse of x is just nothing but the derivative of the kth derivative of tan inverse of x. So remember that we already assumed that the kth derivative of tan inverse of x is equal to, so this becomes p x times 1 plus x squared to the power minus k. Yeah. So now let's derive this using the product rule. So we first, we can derive d by dx of pk of x times 1 plus x squared to the power minus k plus pk of x times d by dx of 1 plus x squared to the power minus k. Okay, so we'll just do this part first. So, for example, if you have a polynomial like x cube, after derivating it, it becomes 3x squared. So what we notice is that the degree is always reduced by 1. If you have x to the power 4, it becomes 4x cubed. The degree has decreased by 1. So in this case, also the degree will decrease by 1. So it becomes p of k minus 1 of x times 1 plus x squared to the power minus k plus pk of x times. So let's derive this. So you can derive it using the chain rule. This becomes minus k times 1 plus x squared to the power minus k minus 1. And then we derive the inside of the bracket. So this becomes 2x. So this becomes p of k minus 1 into x into 1 plus x squared to the power minus k minus 2kx times pkx into 1 plus x squared to the power minus k minus 1. Okay. So I'll just erase the top for more space. So what we have right now is this. So we can factor out the 1 plus k squared to the power minus k. So after doing that, so we've got pk minus 1 of okay, we can factor out the minus 1 also. So pk minus 1 of x times 1 plus x squared minus 2kx pk of x. Okay. So now notice this. So after distributing these brackets and multiplying pk minus 1 of x times x squared, the degree of k, degree of this polynomial will increase by 2. So it actually becomes pk plus 1 of x. And same thing over here also. This is pk of x after multiplying with x. It becomes pk plus 1 and adding them together. We get a polynomial whose entire thing is just pk plus 1 of x. So this is actually just our final result. And notice this, it's the same thing as what we would have gotten if we substituted k plus 1 into the formula, because we can factor out the minus at the top. So this becomes minus k plus 1 like this. P of k plus 1 of x. So this is the same as what we would have gotten if we subbed in k plus 1 in place of n in this formula. So we know that the formula holds consistent for all three, 1, k and k plus 1. So all we have to do now is just write the final statement. So that is, therefore, by principle of mathematical induction, since the formula held true for n is equal to 1, k and k plus 1, it holds true for all positive integers. So that's it. So this is the third question. The quartic equation x to the power 4 plus 2x cubed minus 1 is equal to 0 has roots alpha, beta, gamma, delta. So find a quartic equation whose roots are alpha to the power 4, beta to the power 4, so on, and state the value of alpha to the power 4 plus beta to the power 4, and so on. So let's do a substitution here. We can write y is equal to x to the power 1 by 4. Y is equal to x to the power 4, and we can write x is equal to y to the power 1 by 4. So this means that after substituting and getting rid of all the fractional exponents, we'll be left with a equation whose roots are these. So let's do that. So y to the power 1 by 4 to the power 4 plus 2y to the power 1 by 4 cubed minus 1 is equal to 0. So we have y plus 2y to the power 3 by 4 minus 1 is equal to 0. So 2y to the power 3 by 4 is equal to 1 minus y. Okay, so we can raise both sides to the power 4. So we are left with 2 to the power 4, 16. 16y is equal to 1 minus y to the power 4. It's just 1 minus 4y plus 6y square minus 4y cubed plus y to the power 4. So just subtracting the 16y on both sides, we have y to the power 4 minus 4y cubed plus 6y square minus 20y plus 1 is equal to 0. Oh yeah, actually this part is 16y cubed. After raising to the 4, it's this exponent 3 remains. My fault. Okay. So we have y to the power 4 minus 20y cubed plus 6y square minus 4y plus 1 is equal to 0. So this is the quartic equations whose roots are these. Now let's find the value of alpha to the power 4 plus beta to the power 4 and so on. So this is just the sum of roots of this equation, which is just minus b by a. So in this case, b is minus 20, so just minus of minus 20 by 1. That's 20. So that's the sum of the roots. Okay, find the value of alpha to the power 5 plus beta to the power 5 and so on. So let's take our original equation, which is x to the power 4 plus 2x cubed minus 1 is equal to 0. So we just multiply it by x, we get x to the power 5 plus 2x to the power 4 minus x is equal to 0. So now note this, that each of the things alpha, beta, gamma, delta is a valued solution to this. So we can write alpha to the power 5 plus 2 alpha 4 minus alpha is equal to 0. Okay. So we can add up this. So we get sum of the fifth powers plus 2 times the sum of the fourth powers minus the sum of the roots. Okay. So this is equal to 0 because the sum of all the zeros is just 0. So the sum of, we're trying to find out the sum of the fifth power. So that's just equal to the sum of the roots minus 2 times the sum of the fourth powers. So we can find out the sum of the roots from the first part. It's just minus b by a of this equation. So it's just minus of 2 by 1. Becomes a minus of 2 by 1. And we found out this in the previous part. It's just the sum of the fourth power, so it's just 20. So it's just minus 20 times 2 minus 2, which is minus 42. Okay. Find the value of the sum of the eighth powers. So we can write the sum of the 8th powers as like this. Minus 2 times the yeah. So we already know what this part is. So we found that as 20. So that's 20 squared minus 2 times. So the sum of the roots taken 2 at a time, basically, of the second quartic equation. So that's equal to C by A. So the C over here is 6, so 6 by 1 minus 2 into 6. So it's just 400 minus 12, which is 388. Okay, let's move to the next question. So it's 4a. Use the method of differences to find the sum from 1 to n of phi k by phi r plus k. Okay, so this is the denominator in terms of n and k, where k is a positive constant. So first thing we need to do is partial fractions. We need to split this into two fractions, two separate fractions. So suppose that we can write phi r plus k into, we can write this fraction in this form. So a by phi r plus k plus b by phi r plus phi plus k. Okay. So this, if we like work it backwards, what we get 5k is equal to a into 5r plus phi plus k plus b into phi r plus k. Okay. Now r is the variable here. We can just substitute different values to find out the relation between a and k. So let's try substituting r as minus k by 5 first. So we get 5k is equal to a into 5 into minus k by 5 is minus k plus 5 plus k plus b into 5 into minus k by 5 is minus k again plus k. It's just cancelled out and becomes 0. So this whole part is just 0. So 5k is equal to a into 5. So a is just equal to k. So that's the first thing. I'll note it down here. Okay, and now let's try to eliminate this a part so we can find out the relation of b and k. So let's try this one. Let's try putting r is equal to minus of 5 plus k by 5. So if we substitute it into that equation, we get 5k is equal to a into 5 into minus 5 plus k by 5 plus 5 plus k plus b into 5 into minus k by 5. 5 and 5 just cancels. So we get minus 5 plus k plus k. So 5k is equal to, so this cancels. So we have minus 5 plus k plus 5 plus k. So this just becomes 0. So this whole part becomes just 0 plus b into, so we have minus 5 minus k plus k. So this just becomes minus 5. So 5k is equal to minus 5b. So b is equal to minus k. So let's just rewrite this. Now that we found the values, so you have k and minus k. Okay. So they're asking us to find the sum from 1 is equal to n. So let's add the summation symbol. From 1 is equal to n. So let's first substitute 1, and you'll notice that we start finding a pattern. So we have k by 5 into 1 plus k, which is just 5 plus k, minus k by, so 5r plus 5. So we can just write this part as 5 into r plus 1. So 5 into 1 plus 1, so it's 5 into 10 plus k. Now plus, then add the next one. So for r is equal to 2, so we get k by 10 plus k minus k by 15 plus k. So we have plus k by 15 plus k minus k by 20 plus k, and so on and so forth, until we finally reach n and we get k by 5n plus k minus k by 5 into n plus 1 plus k. So notice all this. This minus k by 10 plus k cancels with this cancels with this, and so on and so forth, until we are left with just this part, k by 5 plus k minus k by 5 n plus 1 plus k. So this is our final answer. If you want, you can factor it and write it as such. So k into 1 by 5 plus k minus k by 5 into n plus 1 plus k. So that's the final answer. It is given that the sum till infinity of that fraction which we found earlier is equal to 1 by 3. Find the value of k. So let's rewrite it. Just got k into 1 by 5 plus k minus 1 by, this should be 1 not k, 5 into n plus 1 plus k. So notice as n just becomes infinity, this denominator gets larger and larger, and 1 by, when you divide something by like a really large number, your result will be really small. So this whole term tends to 0, like basically becomes 0. So what we're left with is k by 5 plus k, k into 1 by 5 plus k, which is just this. So they're given that this is equal to 1 by 3. So 3k is equal to 5 plus k. So 2k is equal to 5. K is equal to 5 by 2. Okay, hence find the sum from n to n square in terms of n. Okay, so what you want to notice is that, for example, 1, 2, 3, 4, until n minus 1, n plus 1, till n square. So the sum from n to n square is just equal to this whole sum from 1 to n square minus the sum from 1 to n minus 1. Okay, so we can write this as the sum from 1 to n square of what the fraction. So we'll write it in the split form, which is, okay, minus, okay, so no need, 1 to n minus 1. So we'll just directly substitute the values. So we found that the sum is k into 1 by 5 plus k minus 1 by 5 into n plus 1 plus k. So we can directly substitute the values. So I'll distribute k again. So it comes like this. So k by 5 plus k minus k by 5 into n square plus 1 plus k minus k by 5 plus k minus k by 5 into, if we substitute n minus 1 over here, so it's n minus 1 plus 1, which is just n plus k. So this k and 5 plus k and this one cancels out. So we're left with k by 5n plus k minus k by 5n square plus 5 plus k. Okay, so we can simplify this further. after factoring out the k, so 1 by 5n plus k minus 1 by 5n squared plus 5 plus k. So we'll be able to simplify it in such a way that the k's are dissolved, basically. The k's vanish. So let's do that. So remember from the previous part that we were able to solve that k is equal to 5 by 2. So after substituting that, we have 5 by 2 into 1 by 5n plus 5 by 2 minus 1 by 5n squared plus 5 plus 5 by 2. Okay. So this just becomes 5 by 2 into, so 10n plus 5, 2 by 10n plus 5 minus 2 by 10n squared plus 10 plus 5. So this 2 cancel out. So, and the 5 cancel out. So we have 1 by 2n plus 1 minus 1 by 2n squared plus 3. So that's our final answer. Okay. Show that the curve with Cartesian equation x squared plus y squared whole square is equal to 6xy. So show that it has this polar equation. So this is pretty simple. So all you have to do is x is equal to r cos theta and y is equal to r sine theta. So substitute those into this equation. So you have r cos theta square plus r sine theta square whole square is equal to 6 into r cos theta into r sine theta. So this becomes r square into cos square theta plus sine square theta whole square. This becomes 6r square cos theta sine theta. So this becomes r to the power 4. Cos square plus sine square is just 1. So it's just r to the power 4. So 6r square cos theta sine theta. So you can cancel this. So r square is equal to 6 cos theta sine theta, which you can write as 3 times 2 cos theta sine theta. And from the identity that sine 2 theta is equal to 2 cos theta sine theta, we can just substitute that and we get r square is equal to 3 times sine 2 theta. Yeah. So that's this one. Okay. The curve C has polar equation r square is equal to 3 sine 2 theta for 0 to pi by 2. So that means on the polar graph, it's just from this line, theta is equal to 0 till theta is equal to pi by 2. Sketch C and state the maximum distance of a point on C from the pole. So to sketch, you can just use your calculator and sum in like the various value of theta. You can make a table like theta is equal to pi by 8, theta is equal to pi by 6, and so on. And keep on calculating values and plotting an approximate point. So if you do that, you'll get something like this. And from the values, it should be apparent that it's symmetrical about the line. This line, theta is pi by 4. So this is the furthest point from the pole. So when theta is equal to pi by 4, we get the furthest distance from the pole. So r square is equal to 3 sine times 2 times pi by 4. R is equal to root of this, root 3 sine pi by 2, which is just sine of pi by 2 is just 1. So it becomes root 3. So the furthest distance from the pole is root 3. Find the area of the region enclosed by C. So for that, the area of a polar graph is given by half of integral from whatever the bounds of integration are, times r square d theta. So in this case, we are integrating from 0 to pi by 2. So we'll take half times the integration from 0 to pi by 2 of r square, which is 3 sine 2 theta. So 3 is a constant, we can bring it outside. So we got 3 by 2 times integral from 0 to pi by 2 of sine 2 theta d theta. So we can just ask ourselves, what is the antiderivative of sine 2 theta? Which means when we derivate which function do we get sine 2 theta. So we can just check. If you derivate cos 2 theta, you get minus sine 2 theta times 2, which is pretty close to what we have, only there's an extra negative and minus 2. So if we add over here a minus 1 by 2, if we derivate it now, then when we derivate it, this gets added and these get cancelled and we're left with sine 2 theta. So this is the antiderivative. So this becomes 3 by 2 times minus cos 2 theta by 2 from 0 to pi by 2. So that's 3 by 2 into minus cos of pi by 2 times 2, which is pi by 2, minus of cos 0 by 2. This becomes 3 by 2 times cos of pi is just minus 1. So this becomes, so this whole part just becomes minus of minus 1 by 2 plus 1 by 2, which is just 1. So it's 1 by 2 plus 1 by 2, which is just 1. So the final answer is just 3 by 2. Find the maximum distance of a point on C from the initial line. So this is the initial line, theta is equal to 0. So they're asking us to find the maximum distance. So it's going to be this point since it has the highest. So if you notice something, that the slope of this point is exactly 0. So dy by the theta is equal to 0 at the maximum distance. So let's find this function. R square is equal to 3 sine 2 theta in terms of y. So we know y is equal to r sine theta. So r is equal to y sine theta. So let's substitute that here. So if y square by sine square theta is equal to 3 sine 2 theta. And y square is equal to 3 sine square theta times sine 2 theta. So y is equal to root 3 times sine theta times root sine 2 theta. Okay, so let's derivate this. So root 3 is a constant, we can just bring it outside. So root 3 times, let's do all the derivative inside. So it's the product rule again. So we'll take the derivative of one times the other. So in this case, cos theta times root sine 2 theta plus, now the derivative of, we keep this one as it is, so sine theta times the derivative of the other. So derivative of root sine 2 theta, let's just do this, the theta of root sine 2 theta. So first of all, if there's a root inside, so the first thing will always be 1 by 2 root sine 2 theta. So that's just like a useful thing to have at hand. So the derivative of root x is 1 by 2 root x. So now following chain rule, we derivative what's there inside also. So derivative of sine 2 theta will just be cos 2 theta. And again, derivate the inside of cos 2 theta. So we get 2. This 2 cancels, so we're left with cos 2 theta by root sine 2 theta. Okay. So this is all equal to 0. So let's multiply it by root sine 2 theta on the full thing. So we can also just cancel out this root 3 because basically dividing by root 3 on both sides we get. So cos theta times root sine 2 theta times root sine 2 theta will just be sine 2 theta plus sine theta times cos 2 theta. So this is equal to 0. Okay, so we can do one thing, and first let's divide by cos theta. So dividing by cos theta, we get sine 2 theta plus tan theta is equal to plus tan theta into cos 2 theta is equal to 0. And dividing by cos 2 theta, we get sine 2 theta by cos 2 theta, we get tan 2 theta plus tan theta is equal to 0. So we get tan 2 theta is equal to minus tan theta. Now in the formula sheet, they have given that tan 2 theta is equal to 2 tan theta by 1 minus tan square theta. So this is equal to minus tan theta. So 2 tan theta is equal to uh, minus tan theta times 1 minus tan square theta. Okay, let me just create some space. So we have 2 tan theta is equal to minus tan theta plus tan cubed theta. So 3 tan theta is equal to tan cubed theta. Okay, so we have a couple of solutions here. One is that tan theta is equal to 0. Okay. Other one is if we divide by tan theta on both sides, we get 3 is equal to tan square theta. So tan theta is equal to uh, sorry, root 3 plus minus root 3. So in the case that tan theta is equal to 0, we have theta is equal to 0. And in the other case, tan theta is equal to plus minus root 3. So we can take tan inverse of root 3. So we get pi by 3. Pi by 3 and minus pi by 3. Okay. Since minus pi by 3 is obviously out of our bounds, so we can just cancel that. And since 0, even technically at 0, there's a stationary point, but that's obviously not the part which has the maximum distance. So it's obviously this part which has pi by 3 angle. So theta is equal to pi by 3. But that's actually not the answer yet. So that's the angle at which the maximum distance happen. So we still have to sub this back into the original equation for r. Okay. So r square was equal to 3 sine 2 theta. So r is equal to root 3 sine 2 theta. If we substitute pi by 3 over here, we get root 3 sine of 2 pi by 3. And just putting this in the calculator, we get okay, so actually what we just calculated was the distance from the pole. But what we have to find is this vertical distance. That's the maximum distance from the initial line. So take a triangle, just look at this triangle. So this is the angle theta is equal to pi by 3. And we have this hypotenuse as, we just calculated it and it was something like 1.611. So this thing will be equal to 1.611 times sine theta. So let's just do that. So the maximum distance is equal to 1.611 times sine of 2 pi by 3. So 1.611 times sine of 2 pi by 3. So it's equal to 1.4. So the sixth question. So the curve C has equation y is equal to 4x squared plus x plus 1 divided by 2x squared minus 7x plus 3. So they're asking us to find the equations of the asymptotes of C. So we check the numerator and denominator have the same degree, which is 2. So that means there will be a horizontal asymptote. So the horizontal asymptote is just the coefficient of numerator, the coefficient of the largest exponent of the numerator divided by the coefficient of the largest exponent of the denominator. So in this case, it's 4 by 2, which is just 2. So horizontal means, so y is equal to 2. And the vertical asymptote, to find the vertical asymptotes, we just need to find the solutions, the places where the denominator is equal to 0. So it's 2x squared minus 7x plus 3 is equal to 0. So you can just solve this on calculator. And we get x is equal to 3 and 1 by 2. So these are the asymptotes. Y is equal to 2, x is equal to 3, and x is equal to 1 by 2. Okay, let's move to the next part. Find the coordinates of any stationary points on C. So the curve C, to find the stationary points, we need to find the places where the dy by dx is equal to 0. So let's just write y is equal to 4x squared plus x plus 1 divided by 2x squared minus 7x plus 3. So dy by dx. So the derivative of a fractional function, for example, if y is equal to f of x by g of x, the derivative of y will be g of x times f prime of x minus f of x times g prime of x divided by g of x square. So dy by dx is equal to 2x square minus 7x plus 3 into the derivative of the numerator, which is 8x plus 1 minus 4x squared plus x plus 1 into 4x minus 7. So that's divided by 2x squared minus 7x plus 3 whole square. And we need to find out where this is equal to 0. So since it's equal to 0, we can just multiply by the denominator on both sides. And we get 2x squared minus 7x plus 3 into 8x plus 1 minus 4x squared plus x plus 1 into 4x minus 7 is equal to 0. So that's 16x cubed minus 56x squared plus 24x plus 2x squared minus 7x plus 3 minus 16x cubed plus 4x squared plus 4x. It's 4x minus 7 minus 28x squared minus 7x minus 7. This is equal to 0. So the 16x cube and this 16x cube cancel. So we've got minus 56x squared plus 2x squared minus 4x squared plus 28x squared. And then we got plus 24x minus 7x minus 4x plus 7x. We have plus 3 plus 7 is equal to 0. So minus 56 plus 2 minus 4 plus 28 minus 56 plus 2 minus 4 plus 28. So minus 30x squared and 28, 24 minus 7 minus 4 plus 7 is 20. So plus 20x plus 10 is equal to 0. So again, we can just put this in the calculator and solve it. So we get x is equal to 1 and x is equal to minus 1 by 3. Substituting these x values into the original function, y is equal to 4x squared plus x plus 1, we get y is equal to minus 3 at x is equal to 1, and it's equal to 1 by 5. So these are the 2 points, 1 and minus 3, and minus 1 by 3 and 1 by 5. Okay. Sketch C, stating the coordinates of any intersections with the axes. So first let's draw the xy plane in rough. So we got y is equal to 2, that's a horizontal asymptote. So we got something like this. Y is equal to 2. We've got x is equal to 3 and x is equal to 1 by 2. So something over here as well. And another one over here. That's x is equal to 1 by 2 and x is equal to 3. So let's also find the intersections. Okay, let's first plot the stationary points. So we got 1 and 1 minus 1 by 1 and minus 3. So it's 1 somewhere over here. We got minus 1 by 3 and 1 by 5. So minus 1 by 3 is somewhere here. And so somewhere over here. And we can also find the x-intercept, which will be, so the x-intercept is drawn here. We can see the y-intercept. Y-intercept is easier to calculate. So the y-intercept happens when the x is equal to 0. So substituting 0 in all of this, we get 1 by 3. So that's one coordinate, 0, 1 by 3. So somewhere here. So this is the point 0, 1 by 3. And there's no x-intercept actually, so it never touches the x-axis. Okay. So just plotting some other points with the calculator to help us, what we get is something that looks like this. And so this is what the graph should look like. Okay. Sketch this curve with the equation y is equal to 4x squared plus x plus 1 and state the set of values for x for which 4x squared plus x plus 1 divided by this is equal to k has 4 distinct real solutions. So this is just the absolute value of the previous graph. So absolute value means whatever was there on the negative gets reflected on top. So it would look something like this. So we got the same asymptotes. So something like this. Now the only difference was before it was something here. This just gets reflected onto the top like this. So remember that this coordinate, this is the stationary point, and it had coordinates of 1 and minus 1 by 3. So this y coordinate was minus 1 by 3. So it actually comes below the, was it 1 second? Oh, it's 1 and minus 3. 1 and minus 3. Sorry. This is minus 3. So after reflecting, this has a coordinate of minus 3. So what they're asking is state the set of values of k for which this graph is equal to k has 4 distinct real solutions. So k means just a line of x is equal to, y is equal to k. So when we draw it through, there should be 4 different intersections like this. So what we'll notice is that it only happens when we draw it above this point minus 3. So if we draw it below, for example, somewhere here, there's only going to be 1 and 2 intersections. So that's not what we want. So that's why the k has to be greater than 3. Okay, so let's move to the last question. The lines L1 and L2 have equations r is equal to 1, 3, minus 2 plus lambda of okay, I can't draw that for some reason, so I'll just move it down. So we got L1 as 1, 3, minus 2 plus lambda of 2, 1, k. I mean 2, 1, 1. And we got L2 as 1 minus 2, 9 plus mu of 1 minus 4, 2. So the plane pi1 contains L1 and is parallel to L2. Find the equation of pi1 giving the answer in your form ax plus by plus cz is equal to d. So in order to find the Cartesian equation of a plane, what we need is two things. We need the normal vector of the plane and we need a point on the plane. So the normal vector will just be, for example, if you have this plane here, we need two direction vectors which lie on the plane. And after cross multiplying them, we can find a normal vector. So the normal vector will be perpendicular to the plane. So let's find this normal vector. So they said that it contains L1. So if it contains L1 means it also contains its direction vector 2, 1, 1. And it's also parallel to L2, which means that it will also have the direction vector 1 minus 4, 2. So you can find the normal vector n is equal to the cross multiplication of these two vectors. So it's 2, 1, 1 and 1 minus 4, 2. We're solving this. So you can do this with the calculator, but you can also do it regularly. So we have 1 times 2 minus 4 times 1. So that's 1 times 2 plus 4, so that's 6 I hat minus. So 2 times 2 minus 1 times 1, which is just 3. 3j hat plus k for k hat. So 2 times minus 4, which is minus 8. Minus 8 minus 1 times 1, which is minus 9. Plus, so that's minus 9k. So we can just write this as 6 minus 3 minus 9. Okay. And we can just simplify this. We'll like remove the common factor. So dividing by 3 throughout, we get 3 minus 1. Oh, sorry, 6 divided by 3 is 2, not 3. 2, minus 1, and minus 3. So there's our normal vector. And to find a point on a plane. So if the plane pi1 contains L1, it also contains any point on L1. So it would also contain this vector 1, 3, minus 2. So we have, so now that we have that, we can write 2 minus 1 minus 3 dot product of times of the vector xyz is equal to 2 minus 1 minus 3 dot product that point on the plane. So in this case, we'll take 1, 3 minus 2. So 2 times x minus 1 times y minus 3 times z. So minus 3z is equal to 2 times 1 minus 3 plus 6. So 2x minus y minus 3z is equal to 2 minus 3 plus 6. So 2 minus 3 plus 6 is minus 1. Minus 1 plus 6 is 5. So there's our answer. So 2x minus y minus 3z is equal to 5. Okay. The plane pi2 contains L2 and the point with coordinates 2, minus 1, 7. Find the acute angle between pi1 and pi2. So same thing as before. So the formula for angle between two planes. So actually two planes, their direction is mainly determined by the normal vector. So in order to find the angle between the two planes, we first need to find the angle between the two normal vectors. So we have another plane just passing through. That's maybe something like this. We can find out. So that one is so cos theta is equal to, so the normal vector 1 dot product the normal vector 2 divided by magnitude of normal vector 1 times normal vector 2, magnitude of normal vector 2. So let's find, we already know the first normal vector as 2 minus 1 minus 3. So n1 is equal to 2 minus 1 minus 3. Let's find n2, so the normal vector of this plane pi2. So it contains L2. So again, in order to find out the normal vector, we need two vectors on the plane. So if it contains L2, it also contains the direction vector of L2, which is 1 minus 4, 2. So it contains this one, 1 minus 4, 2. Now, they haven't given us another vector, but they've given us the point 2 minus 1, 7. Suppose it's just here. So we can, if we have another point on the plane by making a line between them, we'll get another vector. So we can take any line which is on L2. So we can take this one, 1 minus 2, 9. So let's take this point. So we can find 1 minus 2, 9 minus 2 minus 1, 7. So this gives us 1 minus 2 is minus 1. Minus 2 plus 1 is minus 1. 9 minus 7 is 2. Okay. So the other vector was 1 minus 4, 2. So let's take the cross product of these to find the normal vector of pi2. So we have ijk minus 1 minus 1, 2, 1 minus 4, 2. Okay. So minus 1 times 2 minus 8. So that's minus 2 plus 8. So that's 6. I hat minus. So minus 1 times 2 minus 2. So that's minus 4. So minus of minus 4 becomes plus 4 j hat. And minus 1 times minus 4, which is 4. Minus 1 times 1, which is 5. It's 5 k hat. So this is n2. So we have n2 is equal to 6, 4, 5. and we had n1 is equal to 2 minus 1 minus 3. Okay, so now we can put this in the formula and find out the angle. Okay, so we got cos theta is equal to n2 times n1. So we got 6 times 2 plus 4 times minus 1 plus 5 times minus 3 divided by square root of n1, which is square root of 6 square plus 4 square plus 5 square. Let's do that in my calculator. It's root 77 times root of 2 square plus minus 1 square plus minus 3 square times root 37. Okay, sorry. Root 14. So this becomes 6 times 2 minus 4 minus 15. So this becomes minus 7 by root 77 times root 14. So theta is equal to cos inverse of minus 7 by root 77 times root 14. So putting this in the calculator, we get, so just switch back to degrees. So cos inverse of minus 7 by root 77 times root 14. So we get 102.31. But they're actually asking for the acute angle. So we'll take 180 minus this. 180 minus 102.31 is equal to 77.7. And this is the answer. So 77.7 degrees. This is finally the last part. So the point P on L1 and the point Q on L2 are such that PQ is perpendicular to both L1 and L2. Find a vector equation for PQ. So this actually, even though it's a 7 mark, it's a pretty easy question. So let's do. So let's write down P1 again, line 1. So line 1 was 1, 3 minus 2. So L1 was 1, 3 minus 2 plus lambda 2, 1, 1. So you can write this as 1 plus 2 lambda, 3 plus lambda, minus 2 plus lambda. And L2 was 1 minus 2, 9 plus mu into 1 minus 4, 2. Yeah. So you can write this as 1 plus mu minus 2 plus, minus 2 minus 4 mu. Nine plus 2 mu. Okay. So any point P will be given by this. So P is on L1. So P we can write as, okay, so we can write OP, the direction vector to the point P on line L1, as 1 plus 2 lambda, 3 plus lambda, and minus 2 plus lambda. And we can write OQ as 1 plus mu, minus 2 minus 4 mu, 9 plus 2 mu. So PQ is equal to OQ minus OP. So that's the first thing. The direction vector of PQ will be equal to OQ minus OP. So we can write this as, so 1 plus mu minus 1 plus 2 lambda minus 2 minus 4 mu minus 3 plus lambda and 9 plus 2 mu minus lambda minus 2. So we get 1 minus 1 mu minus 2 lambda minus 5 minus 4 mu minus lambda 11 plus 2 11 plus 2 mu minus lambda. Okay, so now they said that PQ is perpendicular to both L1 and L2. Means that, so the test for perpendicularity, the test for to check whether two vectors are perpendicular to each other is to take the dot product and check if it's equal to 0. If the dot product is equal to 0, that means the two vectors are perpendicular. So now we got the vector direction of PQ. Now we just need to cross product this with the vector direction of these two. So 2, 1, 1. So we have 2, 1, 1 as the direction vector of L1 and 1 minus 4, 2. Okay, I can't write there. Okay. So let's do this. So mu minus 2 lambda times 2 plus 1 times minus 5 minus 4 mu minus lambda plus 1 times 11 plus 2 mu minus lambda is equal to 0. So 2 mu, okay, we write it a little neatly. 2 mu minus 4 lambda minus 5 minus 4 lambda minus 4 mu minus lambda plus 11 plus 2 mu minus lambda is equal to 0. So 2 mu plus 2 mu minus 4 mu cancel. Minus 4 lambda minus lambda. So we have minus 5 lambda is equal to 5 minus 11. Sorry, minus 4 lambda minus lambda minus lambda. So it's minus 6 lambda is equal to 5 minus 11, which is minus 6. So lambda is equal to 1. So that's the first thing. We got, so let's note this down here, lambda is equal to 1. And now we do with the other direction vector also. Okay. So we got mu minus 2 lambda times 1. So that's mu minus 2 lambda minus 4 times minus 5 minus 4 mu minus lambda plus 2 times 11 plus 2 mu minus lambda. So this is equal to 0. So you got mu minus 2 lambda plus 20 plus 16 mu plus 4 lambda plus 22 plus 4 mu minus 2 lambda is equal to 0. So now so we got minus 2 lambda plus 4 lambda minus 2 lambda. So these all cancel out. Mu plus 16 mu plus 4 mu. So that's 21 mu. So we are plus 20 plus 22. It's 42. Plus 42 is equal to 0. So mu is equal to minus 42 by 21, which is just equal to minus 2. Oh. Right, let me just put my laptop for charging. Okay, so now we found out the values of lambda and mu for which PQ is perpendicular. So let's substitute this back into this original, this one PQ. Let's see what we get. So putting lambda into this, we got 1 minus 2 into minus 2. So that's equal to, oh, it's a minus 2 minus, sorry. Okay, wait. PQ is equal to minus 2 into 1 minus 5 minus 4 into minus 2 minus 1 11 plus 2 into minus 2 minus 1. So this is equal to minus 2 is minus 4 minus 5 plus 8. So that's minus 5 plus 8, 3, 3 minus 1, 2. 11 minus 4 minus 1, so that's 6. Okay. And we can also just reduce the common factor. So we get dividing by 2 on all sides, on all components, we get minus 2, 1, 3. Yeah. So now we got the direction vector PQ. All we need is a point on the plane and we can form the parametric equation. So any point will suffice. So we can take any point on L, not any point actually. We have to substitute lambda into this. So we find the point at which intersects the thing. So at lambda is equal to 1, OP is equal to 1 plus 1, 2, minus 2 minus, oh, so it's mu. 1 minus 2, which is, I'll write it here. Actually, no. OP is equal to, oh, okay, 1 plus 2 into 1, 3. 3 plus 1, 4. Minus 2 plus 1, minus 1. So we illustrate this PQ is equal to, create some space. PQ is equal to 3, 4 minus 1 plus t, any variable, into minus 2, 1, 3. So you can do the other thing. You could substitute mu is equal to minus 2 here also and use that in place of this value. But this is my final answer, so it's correct. So that's it. I think so. This is the last question. So that's the end of this video.
All right, thank you, Siddharth, for explaining to us all the things that we need to know for this paper. And thank you all for listening to this video. Don't forget to hit the subscribe to stay tuned for more episodes coming in the way. Thank you and goodbye.